There's a lot going on in these two paragraphs, so I want to make sure that everything is clarified. Many object-oriented languages, Java and C# among them, allow the programmer to define types for which initialization of dynamically allocated variables occurs automatically, even when no initial value is specified in the declaration. What this means is that you can have constructors without arguments. Some languages, notably C++, also distinguish carefully between initialization and assignment. In C++, initialization is interpreted as a call to a constructor function for the variable's type, with the initial value as an argument. In C++, assignment is interpreted as a call to the type's assignment operator, or, if none has been defined, as a simple bitwise copy of the value on the assignment's right-hand side. What we're saying here is important. When we deal with simple types like integers, if we assign a value to x, then copy that value to y, and give x a new value, we know that the value of y won't change. With user-defined classes, however, we don't have that guarantee in C++. If each object consists entirely of simple types, then assignment works like we expect and you get two separate copies. If our original object has a pointer to someplace in memory, however, what gets copied is the value of that pointer, meaning that both objects are now pointing to the same space in memory, and a change to one can also change the other. This is often referred to as a shallow copy. A deep copy of an object will make a distinct copy of the entire object, including all data structures that are pointed to by that object. The distinction between initialization and assignment is particularly important for user-defined abstract data types that perform their own storage management. In other words, for user-defined classes that implement deep copying. A typical example occurs in variable-length character strings. An assignment to such a string must generally deallocate the space consumed by the old value of the string before allocating space for the new value. An initialization of the string must simply allocate space. This means that creating a new object and assigning a value to it requires the constructor to allocate space for the string initially, and then deep copy has to reallocate space for the new string, all of which is less efficient than just initializing the object with the string in the first place. In Java, there is no distinction between initialization and assignment because Java uses a reference model for objects. In Java, nothing gets copied and both variables refer to the same object.